Hello, welcome. Today we're going to be talking about section 2.2, which is graphs of functions. In the past, we learned how to graph by plotting points. Let us graph the following by plotting points and finding the end behavior. This thing about the end behavior is something that we always discuss in calculus because we want to know what happens at the end points of the curve. Okay, we want to know where it's going. So let me go ahead and give you an example. So I'm going to start by graphing by using plotting points. And this is what we learned in the previous section. So for example, let's just say I select -2, 0, and 2. Let me go ahead and start one more time. My pen was not working out. -2, 0, and 2. Okay, I'm gonna plug in those values in here. So then this will be y is equal to a -2. Y will be equal to 0, so I'm gonna replace that x with that value. And then y will be equal to 2. Okay, so now let me go ahead and graph it. Okay. I do recommend you guys to use a ruler, just because it's better to use a ruler than if you do not have a ruler. Okay, so then I'm gonna label the -2 and the -2. Point it's like right here, and then 0, 0, and then 2. And you can see right here that I have my line that goes like this. Okay, now I'm gonna discuss what I want with the graph. Okay, basically what I want, or the idea of the end behavior, is what happens as I take very large values of x. Okay, and I only selected it a few values right here. I only selected it a few, which is 3, but you can make your t-table values larger if you wanted to. For example, what happens as I select 1,000, -1,000, and if I plug it into the function, then this is also going to be -1,000. Or if I select 100, when I input it, this will be equal to 100. Or if I give an input of 3,000, positive 3,000, and I plug it into the function, or this is your function, you're replacing the variable x with each value here, each value that you're giving it. And so then in this particular case, I'm going to get 3,000. So what I want is, I want to know what happens as I pick very large values that are positive and then very large values that are negative. Okay, if I pick the first one very large value that it's negative, I can see that the y value is going to go into the negative direction. So it's going to go this way. So then I need to say it somehow. So I'm going to say it this way. I'm going to say it as x goes to the negative direction. This negative direction means as I select very large negative numbers, my y value, remember this is your y value here, it's going to the negative direction. Let me erase my circle here. And this is one part of your end behavior. Now, as I select very large positive values, okay, like the positive 100 and then the positive 3,000, I can see that my y value is also a very large positive. So then my y value, which is my function f of x, is also going into the positive direction. And this is what we call the end behavior. This is the exact way that we write it down. You can also think for our class this way? Well, since if I pick very large negative values of x, it's going to drop to the left, okay? Drop, you're thinking about the arrow. So it will drop left and then it will rise up to the right. We can think that way for our class. But if you're planning to go to calculus, then you have to do it this other way. Okay, let me go ahead and move on to number 2. We have x squared. Okay, and if I do it the same way, okay, let me go ahead and pick -2. I will pick 0 and 2. Let's see what happens. Okay, so then this is going to be y is equal to -2 squared. That will be equal to 4. Plug in the 0, 0 squared, that will be equal to 0. Plug in the 2 squared, that will be equal to 4. And I think we are ready to plot the points and then graph. Okay, so I have a -2. We have 0 and 2. Okay, at -2, we have 4. 1, 2, 3, and 4. So then I have this point right here, -2 and 4. And then I have the point 0, 0. And then I have the point 2 and 4. Okay, the other time we discussed this graph, and we said that every time we have a square, okay, I hope you guys remember that square, you will have a parabola shape. So this is a parabola. And the parabola, it's a U shape. Okay, what's the end behavior? The end behavior is as I pick very large negative values of x. I don't care how big they are. You can make a T table if you want to. So think like if you're going to be moving in this direction here with where I'm writing the little dots, you're going to be selecting a very large value, negative value of x. So we can say -100. And you're going to plug it into your function. And when you do, this is going to give you 10,000. If it gives you 10,000, you can see that it's positive. So this is going to be going to the positive region. Okay. Now, as x is going to go to the positive, I pick a number that is super large on the positive side, this side over here. So let's just say I pick 300 and I plug it into the function, then this will be 90,000. Super large, but it's going to go to the positive direction also. This will be my end behavior right here. In terms of arrows, I know that it will rise to the left and it will rise to the right. Okay, for our class, what you want is you just want to know what's going to happen at the endpoints. We just care about what's going to happen at the endpoints of the graph. Is they are both going to go up, or is one going to drop left and the other one's going to rise, or vice versa? And that's what we care about. But if your goal is to go all the way to calculus, then you want to understand this notation. Okay, let me go ahead and move on to the next one. We have x to the third power. Make a T table of values. This is what we call the cubic function. Now, cubic function, we'll try the same thing. I'm going to try -2, 0, and 2. You can try more values if you want to. Okay, for me, this will be enough. So I'm going to plug in the -2. So then this will be y is equal to -2 to the third power. That will be equal to a -8. Y will be equal to 0 to the third power, which is equal to 0. And then y will be equal to 2 to the third power, which is equal to 8. Okay, I am ready to graph. Okay, so then I have a -2. And then we have a +2. And then I can see that I have on the y's, it's going to be an 8 and a -8. So this is 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7. And then I need one more. We will call that a -8. Okay, so now I'm going to label the points. I'm going to start with this one, -2 and -8. It's like about here. 0, 0. And then 2 and 8. Okay, to some of you guys, this might look weird. If you think it's a line, don't even think about it. So if it looks to you like a line, select more values. So notice that I kind of skip the -1 and the 1. So I'm going to test -1 and 1. So if it looks to you like a line, let's try more values in the middle. Okay. So I'm going to try -1 and 1, and I'm going to plug it in. So this will be y is equal to -1 to the third power. That will give me a -1. Y will be equal to 1 to the third power, and that will be equal to a 1. Okay, so I have two more values. Let me see, -1 and -1, it's about here. And then I have a 1 and a 1. Okay, that is better. This is better because now I know that it's not really a line. Okay, now let's see. Do I need more values? In case you need more values, you can select more, like -3 and 3. Okay, if that's the case, you just plug in more. So if this is -3 to the third power, this will be equal to a -27. And when I plug in the 3, this is going to be equal to a +27. And so then you can see that if I try to label the -3, it's going to be somewhere a lot lower that I cannot really graph, okay? If I try 3 on this other side, then you can see that it's going to be somewhere really high. Okay, but I can see the graph. So here's the graph. It's going to go like this. You know, eventually it's going to come back down. Let me go ahead and erase the little black dot right here. In your paper, it should be better. I call it the snake shape because to me, in my eyes, it looks more like a snake, but it's up to you. Okay, but it's called the cubic function. This will always be the graph of the x to the third power. Okay, what about the end behavior? Okay, well, I can clearly see that as x goes to -infinity, I can see the y values, yeah? I can see that this arrow is going down, so it's going to go to the -infinity. As x goes to infinity, I can see that f of x is going to go to the +infinity. And that's it. This is my end behavior. I can see that it drops to the left and then it rises to the right. And so then I will just keep it that way. And that will be it. Okay, in this case. Now, something that I didn't mention because I was leaving it to the end. As you can see, I can have some other graphs, for example, this one right here that I didn't go over. But as long as I know how the x squared behaves, this one's going to have the same shape. It's going to have the same behavior at the endpoints of the graph, okay? That's the reason why we call it the end behavior. You can see the last one that we just did, it has a third power right there. And because it has a third power, that I know that it's going to drop to the left and it's going to rise to the right. A lot of things might happen in the middle or in between, but this is what's going to happen at the endpoints. Okay, now the leading coefficients have always been positive, so we won't worry about the negative at another time. Let's talk about rational functions. Okay, rational functions is when you have a fraction. Okay, so here's a fraction. And so then if I have a fraction, one of the problems that I have is the domain. Okay, so some things to consider is the domain first. Okay, the domain is the denominator here. So that means that I have to consider that denominator here. Okay, so I'm gonna get the denominator, and so it's x, and x cannot be equal to 0. Okay, so that's what I'm going to consider first. Now I'm going to make a t-table of values. This will be x and y. And so this is what I'm going to have when I do this graph. Okay, I have something that it's called an asymptote, okay? I have an asymptote. An asymptote, you can think of an asymptote as like a boundary. That boundary is basically the number that it cannot be equal to, which happens to be 0. So it's like if you have a boundary right here on top of your y-axis. It cannot be equal to that number. So that means that whatever your graph is, you cannot cross the orange asymptote. Okay, that's what we call an asymptote. Okay, so now I gotta select values. Okay, but the values that are close to the orange asymptote is 0. So then I need to pick numbers that are very close to 0 from both sides. When I say both sides, I am talking about this side right here, very close to the asymptote, and then to the right. Okay, what happens to the right? So from both sides, we'll have 2 sides, yeah? Okay. So then this is the way I'm going to do it. I'm going to select something far away. So let's go ahead and try -10. And then we're gonna try -1. And then we're gonna try -0.1, which is something very small. And then I'm going to repeat the same ones, but the opposite sign. So 0.1, and then 1, and then 10. And this is just to know what's going to happen. Okay, now go ahead and use a calculator. And you need to plug in this value into your function, okay? So when you do, this is going to be y is equal to 1 over -10. As the decimal, it happens to be -0.1. So this is -0.1. Okay, go ahead and plug in the -1. When you do, this is y it's equal to 1 over a -1. That's equal to a -1. Plugging the -0.1, y equal to 1 over a -0.1. Now, when you're doing these problems, you have to use your calculator, otherwise you're gonna struggle. I get a -10. Okay, when I plug in the 0.1, the positive 0.1, I get 10. When I plug in the 1, I get 1. When I get 10, when I plug in 10, I get 0.1. Okay, so now I am ready to plot the first point. This is -10 and -0.1. Right here, it's very, very small. There's my point. -1 and -1. So I'm gonna label, let me go ahead and label a few values here. So I'm gonna label it as +1 right here, and then as 2, and then as 3, and we are gonna label 10 here, just because I cannot fit all of those values in here. So I'm gonna label like -1 and -2 and -3, and I'm just gonna say that -10 is somewhere over here. Okay, so now at -1, I have a negative 1. So it's like here. And then at negative 0.1, it's negative 10. So something very small to the asymptote. It's not equal to, but it's very close to the asymptote. So then my graph goes like this. I'm going to connect them. It looks like this. Once again, if you don't think it's enough points, you can pick more. You can pick more values. For example, maybe you can pick a negative 5 if you want to, just to see where it's at. You can pick negative 100 if you want to, etc. Okay, so now let me go ahead and do the other ones. 0.1, it will be 10. So somewhere over here. And then we have 1, it will be 1. And then you have 10 and it will be 0.1, something very small. So then you can see that it will go here like this. That will be the graph. You gotta memorize this graph, okay? The graph of this rational function will always look like this, like that graph that you see here. I'm kind of highlighted for you. Okay, what about the end behavior now? What about the end behavior? Okay, for this one, we have several end behaviors, and I would like to write the end behaviors after. So I'm going to do the end behaviors after. Okay, let's go ahead and do the last graph. Okay, so I will do the same thing. I'm going to plug in something very large. Let's try a negative 2 and a negative 1. And let's try a negative 0.1. You can see that this time around I'm selecting more. 0.1, 1, 2, and 10. Okay, once again, the denominator here is an x squared. And so if this is x squared, it cannot be equal to 0. So I know that x cannot equal to 0. And since I already know that, then that's the reason why I selected it, these values here. I need to know a number that it's very close to 0 from both sides, okay? Okay, so now I'm going to find those values. So I'm gonna plug them in, okay? So use your calculator, so this will be 1, negative 10 squared. And so when you do it in the calculator, make sure you do it carefully. It's 1 divided by parentheses 10 squared, okay? And that will be equal to 0.01. Okay, plug in the next one. Y is equal to 1 over negative 2 squared. And that will be equal to 0.25. Okay, then plug in the negative 1, and this will be 1 over a negative 1 squared. And so then that will be a 1. Plug in the negative 0.1, and so then that will be y is equal to 1 over negative 0.1 squared. So then that will be equal to 100. Since I'm plugging in the same values, most likely they're going to repeat, but you can keep on doing this. 1 over 0.1 squared, that it's going to be equal to positive 100. plug in the 1 and you will get a 1, plug in the 2 and that will be 0.25, plug in the 10 and that will be 0.01. Okay, now go ahead and do your graph. I need to erase this because of the space. Okay, so let me go ahead and quickly erase this and then go ahead and label it. Okay, remember that I have an asymptote right here. X cannot be equal to 0. Okay, so now I'm going to label the points. So -10 and 0.01. So let's just say -10 is here. It's right here. It's positive. All of them are positive. -2. You know what? Let me go ahead and draw this better. 1 minute. Okay, so then I can have -10.1, 0.01 is very small, and then -2 and 0.25, that's something a little bit bigger. And then -1 and 1, I'm gonna label my 1 like right here. And then -0.1 and 100, so something I will say like over here. And then I can make my connections right here. Like this. Okay, I'm gonna do the other one. So then it's 0.1 and 100. So this is going to reflect on this other side. And so then it's 1 and 1. And then it's 2 and 0.25. And then it's something very small over here. And we're gonna do the same thing. We're gonna connect it. And this is the graph always for your x squared, okay? This will always be the graph for this one. Okay, what about the end behaviors for this particular two graphs? Well, the end behaviors for these particular two graphs are going to be very different. We will have several end behaviors because we will have to discuss not only the infinite behaviors, like in this particular case, the only thing that we want is what happens at the endpoints of the graph. But can you see that these graphs have 4 endpoints? Okay, for example, let me go ahead and highlight the last one. There's an endpoint right here. There's an endpoint right here. There's an endpoint right here. And there's an endpoint right here. You can see that we have 4 of them. Okay, so I'm only going to do one of them. Okay, also the first one over x, has also four endpoints. Okay, so I'm gonna do it this way. So I'm gonna say as x goes to infinity. The one that goes to infinity, we're talking about number 1. I'm gonna label it with a number 1. We're talking about that arrow. Okay, and so then I can see that as x goes to infinity, f of x seems to be getting closer to 0. And you can see it here on the answer. If I pick a very large number like -10, the answer is 0.01. But let's just say you wanted something larger than -10. You can try -100 and plug it in, and you can see that you're going to be getting close to 0. Okay, what's the other endpoint? I'm gonna label it with a number. I'm gonna label it 2. As x goes to the negative infinity, Okay, so I'm gonna label it. This is 1, this is 2. F of x, it's also going to 0 right here. Okay. Now I need the 2 endpoints in the middle. What's happening in the middle is that I'm approaching no longer the infinity part, but I'm approaching the 0, which is this one right here. Okay. I'm getting close to this point right here, yeah? Okay, so I'm gonna label it 3. As x is approaching 0, but now I gotta tell you from which side. I have 2 sides, and I'm approaching 0 from both sides. Okay, we call this side the left side. So we're gonna say a negative right here, and that says left. And your y value, it's going to infinity. And then I'm gonna label 4. And then as x goes to 0 from the right side, this side is the right side, then f of x is also going to infinity from this side. This one has 4 end behaviors. Now, are you going to be working with a lot of rational functions in this book? No. Mainly, you're going to be working with polynomials. But once again, if your goal is to go to calculus and you kind of want to understand at least some of the basics, that we do spend a lot of time there. Okay. Okay, so then I'm going to leave this one for you guys. Okay, so try. Maybe I will guide you through it. Okay, so I'm gonna start by just giving you a T table of values. And we're gonna start maybe with -3 and -2, -1, 0, 1, 2, and 3. Okay. Go ahead and do the graph. So you evaluate. Go ahead and do the graph on your paper. And so we had a -1 here, a -2 here, a -3. Okay, so please go ahead and start right here. And if you have any questions, please ask me during office hours. Okay, hopefully you guys will be okay. Let me go ahead and move on to graphing a piecewise defined function. A piecewise defined function, I believe we kind of talked about it last time. We said that a piecewise defined function defines 3 pieces in a graph. And I kind of gave you an example. I said, look, sometimes there's graphs that have pieces of a graph. For example, I can give you some part of a parabola, and then I can give you some part of a line, and then I can end with some part of a radical, you know? And this is what we call the piecewise defined, because you have 3 different pieces of 3 different graphs, okay? And so then this is what we're going to learn how to work with in this section. Okay, so the first thing to understand is that you have 3 pieces. Okay, so this is 1 piece, this is the second piece, and then you have the third piece. You have 3 pieces. So you wanna separate all of them, okay? So I'm gonna start by saying this is y. So I'm gonna say y is equal to 3x. And then they give you a condition, x is less than 0. I'm gonna make a T table of values here. You always start right here, always, always. I know it says less than 0, it's not equal to, but you're still going to start at 0. So that one tells you where to start. So we're gonna select 0 for x, and then it says x is less than 0. So something less than 0 is -1, and then I can pick a -3. And I'm gonna plug it in. And so then when I plug it in, I get y, it's equal to 3 times 0, which is equal to 0. I'm gonna plug in the -1. And so this is 3 times -1, it's equal to a -3. I'm gonna plug in that -3. And so this is 3 times -3, it's equal to a -9. Okay, you are going to label this point right here that it's not equal to has a hole on the graph. Okay, that one has a hole. Okay, I'm gonna move on to the second part of the graph. Okay, the second part of the graph says y it's equal to x plus 1, and it has the condition. The condition says x is between 0 and 2. Okay, and so that's what I'm going to do. I'm going to select all the values that are in here. Okay, so I'm gonna start with 0, and then 1, and then 2. Okay, I'm gonna find them. Okay, so I'm gonna plug in the 0. So this is 0 plus 1, this is equal to 1. Plug in the 1, 1 plus 1, that's equal to 2. Plug in the 2, I get 2 plus 1, it's equal to 3. Okay, both of them are equal to. Okay, right here we have the inequality, and the inequalities are equal to, so there's no holes right there. Let's go ahead and do the last part. Okay, so then for the last part, you have a y, it's equal to x minus 2 squared. And then it gives you the inequality, x is greater than 2. I'm gonna make a t-table of values again, and I'm gonna start right here. It tells you greater than 2. So we're gonna start right there, not equal to 2, but greater than 2 was 2, 3, and then 4, I will pick 4. Okay, at 2, we're gonna have another hole. So let me go ahead and label it with pink color here so you know that it has a hole. Let me go ahead and find the other values. So then I'm gonna plug it in. This will be 2 minus 2 then squared. That will be a 0. Y is equal to 3 minus 2. That will be a 1 squared. That will be a 1. Plug in the 4. That will be a 4 minus 2. That will be 2 squared. That will be a 4. Okay, now I'm going to graph it, okay? I'm gonna graph this one. Okay, so I'm gonna do it on this side because I tend to write kind of big. Okay, I'm gonna start by labeling the first one. I'm gonna label it yellow. So this one's going to be the yellow graph. This one's going to be green. And then this one's going to be blue. Okay, so here we go. So I'm gonna start here. So I'm gonna label 0, 0, not equal to, so just a hole. Put a hole right there. And then -1 and -3. Right here. And then -3 and -9. I'm gonna label it -9, so it's like about here. And we are going to connect them. And because this one says that x is less than, then I know that I have an arrow that goes like this. It goes like this over here. Okay, I said I was going to label it yellow, but because it's kind of hard to draw it with the yellow color, here it is. Here's my yellow color graph. It has a hole right there. Okay, now I'm gonna move on to the next part. The next part, is the green one. And so then that will be 0 and 1. So 0 and 1, it's like about here. And then 1 and 2. And then we'll have 2 and 3. This is 1. This is 2. And this is 3 here. So it's like this piece of the graph only right here. And then last, I have the blue one. And so then the blue one will be 2 and 0. And it has a hole. Then 3 and 1. And then 4 and 4. Something's wrong with my last one. So let me go ahead and fix it. Okay. I think I graphed the last one wrong. So let me go ahead and erase it. Let me just make sure that I'm doing it right. We have 2 and 0, and then 3 and 1. 3 and 1. And then 4 and 4. Okay, so it seems like if it's like this, more like this. It's not really a line. And then for me, just to confirm it, I can select more values if I wanted to. Okay, this is it. This is your piecewise defined function. Now, the hardest part of graph. What's the hardest part? All of these things are hard, but the hardest part is, can you give me the domain of your graph? Give me the domain of that graph. Okay, so then the domain is, where does it start? Okay, so it doesn't start because it goes all the way to infinity. So it doesn't start. So it starts at negative infinity. And then where does it stop? Okay, well, we have a hole, but then this one's included. The green part is included on that same 0 part. Okay, so then it never stops. So your domain is all real numbers. Okay. Your domain is negative infinity to infinity. What about the range? So this is your domain here. And then what about the range? The range is what's the lowest point on the graph. So then the lowest point is negative infinity also, because this is going all the way to infinity. So it's negative infinity. What's the highest point? This arrow right here, it seems like it's going to be growing. So it's also infinity. So negative infinity to infinity. That's it. That will be the answer for this one. Okay, this is a piecewise defined. Now, something that caught my attention is I got the next problem from your textbook, and it's problem number 43. And so problem number 43 happens to be this one. This is a piecewise defined function. It says 0 and 3, but if the absolute value of x is less than or equal to 2, or the absolute value of x is greater than 2. So let's go ahead and go over it. I'm going to separate it. So this will be y is equal to 0 for the first part. And then absolute value of x is less than or equal to 2. The hard part is the absolute value, okay? Because absolute value is you gotta find all of the numbers that can satisfy this condition, okay? For example, if I plug in a 1, absolute value of 1 gives me a 1, okay? So I'm thinking like this on my number line. What numbers can I pick that satisfies this condition? And so I think it's between -2 and 2. All of the numbers in between here satisfy this absolute value thing. Because if I pick a -2, the absolute value of -2 is a 2. And 2 is not less than, but it is equal to 2. So then this is x is between -2 and 2. Okay, so with that in mind, I'm gonna make a t-table of values with that. And I'm gonna pick those values. This is -2, -1, 0, 1, and 2. And I'm gonna find what they're equal to. So let me go ahead and plug it in. Wait, plug it in. There's nowhere to plug it in. I just have a 0. We don't have a variable. Okay, so we only have a variable, then this is always 0. Okay. Moving on. Let me go ahead and do the other one before I label it. So then I'm gonna label it in green. So then this will be y is equal to 3. And then we have absolute value of x is greater than 2. But I gotta think again what satisfies all these conditions. And so it will be x is greater than 2 or x is less than -2. That will satisfy all of those conditions. Okay, so then I'm going to make a t-table of values also. And I'm going to start with 2. And then I'm going to pick values where x is greater than 2. So greater than 2, it will be, let's see, 2 and 3, and then I will do 4. And of course, we'll have more. And then I'm going to pick values of this one here. So it will be -2, and anything smaller than -2, so -3 and -4. So I'm going to do both. And then I know that this one will have a hole because it's not equal to. And at -2, it's also going to have another hole right there. Okay, I'm going to find them. So let me go ahead and plug them in. I plug in the 2. Once again, there's no variable to plug it in. So this is always a 3. Okay, so now let me go ahead and do the graph. Let me label a few of the points. So then this is a -1. Then I have a -2 here. Then we have a -3. We have a -4. I'm going to label that to me a -5. Then we have a 1, a 2, a 3, a 4, and then a 5. 1, 2, 3, 4, and 5. And then 1, 2, 3, and 4. And then I'm just going to label all the way to a -5 also. Okay, I'm ready to label the values. Okay, I'm going to make the first one blue. Okay, so I'll make this one blue. So then it will be -2 and 0. Okay, right here. And then -1 and 0. Then 0, 0. Then 1 and 0. And then 2 and 0. And you know what? I'm gonna change the color. I'm gonna make it pink. And so if I connect all of these dots, I just have this line right here. Okay, now I'm going to do the other one, and I'm gonna make the other one green. And so this will be 2 and 3. And it has a hole. And then 3 and 3. And then 4 and 3. And then it will be a 5 and a 3 because it says it's greater than. So it's going like this. And then the other one, it will be a -2 and a 3. And then a -3 and a 3. A -4 and a 3, a -5 and a 3. And so forth is going to come this way. And this is the graph. This is your piecewise defined function. Okay. Okay, now what's the domain? Okay, I gotta think of the lowest point on the graph, and you can see that the arrows here are telling me that it's going to continue forever. So then this will be a -infinity. And then it never stops, so to infinity. What about the range? Well, for the range, we don't have anything. We only have this value right here, which is 0, and also the 3. And so we're just going to say 0 and 3. And that's it. That would be the answer here. I know it's a little hard, but hopefully you guys will be okay. Okay, we're almost done with the lesson. It says, can you decide if this defines a function, yes or no? Okay, so does it define a function, yes or no? And so it's not easy to be able to define if it's a function, but you can try by doing it by graphing, okay? And so then, for example, I would move the 5 and I move the y, so this will be 3x squared minus 5 is equal to y. So then I can say that y is equal to 3x squared minus 5. And I know, because I told you that I will have a squared, x squared. I know it's a parabola shape. So it's like this. And so it is a function. It is a function. It does define a function. The definition for a function, we talked about it in, I believe in section 2.1, and the definition of a function says if you can put any unique input, you have an input, and then you get an output. But whatever your input is, it's unique. And of course, this one's going to be unique because if I input a number here, whatever the number is here, it's just going to be in here. It's not going to repeat. If I give it an input right here, it's just going to give me this output. If I input something in here, it's going to give me a unique output. So that would be a function. Okay, what about the second one, B? Okay, for B, it defines, we also talked about it in 1.9. We said that it will have two things that have an x squared, okay, with a plus sign. It will define a circle for us. Okay, so this one's a circle. And because it's a circle, we know that we have a center, and the center in this case is 0 and 1, with the radius in square root of 4, which is equal to 2. And if I just think of the graph, okay, this is 0 and 1, here's the center. And I'm going to move 2 units up, 2 units down, 2 units to the right, 2 units to the left. I have the circle right here. And this one is not a function. And you can think of the input and the output if my input is 0, if my input is 0, I'm going to have 0 and whatever this value is, okay? So if x is 0, I might get a -1. And then when x is 0, I get a 3. So then I get 0 here, and then 3, 0, and -1. My input here, it's no longer one input. It's no longer unique. My input has 2 outputs. And for the function, this cannot happen. Your input has to be only one, and it has to be unique. That's the reason why this one is not a function. Okay, well, with practice, you're going to get good at this. I am totally done with section 2.2. If you have any questions, please come see me, okay? Ask me questions. Bye.